Welcome, everyone, to this exhilarating video. Get ready to embark on an unforgettable journey of knowledge, inspiration, and entertainment. Together, let's dive deep, challenge boundaries, and unlock the door to endless possibilities. Let the adventure begin. History of Assembly Language. Assembly language is a low-level programming language that closely represents the machine code instructions executed by a computer's processor. It is often referred to as a second-generation programming language because it is one step higher than machine code but still closely tied to the hardware architecture. In this article, we will explore assembly language in detail, including its purpose, syntax, memory management, and how it relates to computer architecture. Assembly language has a rich history that dates back to the early days of computing. The development of assembly languages can be attributed to the need for more efficient and human-readable alternatives to machine code instructions. The first assembly languages were developed in the late 1940s and early 1950s for early computers like the EDSAC, Electronic Delay Storage Automatic Calculator, and EDVAC, Electronic Discrete Variable Automatic Computer. These assembly languages were specific to each computer and closely mirrored the machine code instructions of the respective systems. The concept of assembly language gained more prominence with the advent of high-level programming languages in the 1950s, such as Fortran and Lisp. These languages allowed programmers to write code using English-like statements, which were then translated into assembly or machine code instructions. As higher-level languages evolved, they provided a more abstract and portable way of programming, reducing the need for direct assembly language programming. The concept of assembly language as a separate language and programming paradigm solidified in the 1960s with the emergence of more sophisticated computer architectures and processors. Assembler programs, which translated assembly language into machine code, became essential tools for software development. Introduction to assembly language. Assembly language serves as a bridge between high-level programming languages and machine code. Unlike high-level languages such as C++, Java, or Python, assembly language instructions are directly understandable by the computer's processor. Every computer architecture has its own assembly language, tailored to its specific instruction set and organization. Purpose of assembly language. The primary purpose of using assembly language is to have precise control over a computer's hardware resources. It allows programmers to write code that can directly manipulate registers, memory, and other system resources. Assembly language is commonly used in scenarios where efficiency and low-level control are critical, such as operating systems, device drivers, embedded systems, and performance-critical applications. Syntax of assembly language. Assembly language syntax varies depending on the specific architecture. However, there are some common elements and conventions that apply to most assembly languages. Typically, assembly language instructions consist of an operation code, opcode, that represents the desired operation to be performed, along with operands that specify the data on which the operation is performed. The syntax also includes directives, labels, comments, and registers. Directives provide instructions to the assembler about how to process the code, while labels are used for program organization and control flow. Comments provide explanatory text for humans and are ignored by the assembler. Registers are temporary storage locations within the processor used for fast data manipulation. Memory management in assembly language. In assembly language programming, memory management is done manually by the programmer. The programmer needs to explicitly allocate and deallocate memory, as well as manage the movement of data between memory and registers. This manual memory management allows for precise control over memory usage but also requires a deep understanding of the underlying computer architecture. Assembly language provides instructions for accessing memory locations, such as loading data from memory into registers and storing data from registers into memory. It is the responsibility of the programmer to ensure that memory is used efficiently and that potential issues like buffer overflows or memory leaks are avoided. Relationship between assembly language and computer architecture. Assembly language is intimately tied to the underlying computer architecture. Each instruction in assembly language maps to one or more machine code instructions executed by the processor. Therefore, understanding the computer architecture is essential for effective assembly language programming. Computer architecture encompasses the organization and design of a computer system, including its processor, memory hierarchy, input/output systems, and interconnectivity. Assembly language instructions are designed to directly interact with these hardware components, making it crucial to understand their workings and limitations. Advantages and disadvantages of assembly language. Assembly language offers several advantages, including efficiency. Assembly language programs can be highly optimized, as they allow for fine-grained control over system resources and memory management. This efficiency makes assembly language suitable for tasks that require maximum performance. Low-level control. Assembly language provides direct access to the hardware, enabling programmers to exploit specific features and instructions of the underlying architecture. Portability. Assembly language is architecture-specific, but it can be ported to different systems with compatible instruction sets, allowing for reuse of code in similar environments. However, there are also disadvantages to using assembly language. Complexity. Assembly language programming requires a deep understanding of computer architecture and low-level concepts. It can be challenging for programmers accustomed to high-level languages. Development time. Writing programs in assembly language generally takes longer compared to higher-level languages due to the need for manual memory. Thank you for joining Tidbits Hub. If you enjoyed the video, please support us by subscribing, liking, commenting, and sharing. Your engagement fuels our growth and inspires us to create more amazing content. We value your presence in our community and eagerly anticipate your return for our next video.